Hello students, this is a video on the topic tests that we have prepared for you to help you gauge your preparation based on each topic. Once you're done with the basic concepts of the topic, all you have to do is go through these tests to understand whether you're able to apply those concepts in a test or not. Once you do give a test, that is when you go through this video to get an understanding of what could have been a decent attempt, which questions to look at, the kind of time that you want to spend on each question. And if you do like the tests and the videos, there are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. Please download the app and go through those videos and make use of these tests that we have prepared. Now, this specific video is about the topic number system, subtopic being properties of numbers, and this is test number 2 on this topic. Overall, I thought this test was towards higher level of difficulty. An attempt of maybe 5 to correct questions, 5 to 6 net correct questions would have been a really good attempt, and the attempt time would be easily 25 odd minutes because there are questions where cases were being formed, and those kind of questions take time. Even if you've cracked the question, you have to go through multiple cases, which ends up taking time and therefore attempt on the higher side. And since some of the questions were difficult, attempt number on the lower side. Now, if we do look at the questions, question number 1. A is a set of all the integers from minus 200 to 200. How many subsets of A having exactly 399 elements can be formed such that the sum of all the elements in each subset is either 1 or minus 1? Now, if we look at the sum of all numbers from minus 200 to 200, on one side we'll have the negative number, on the other side we'll have the positive number. So the sum will be 0. And the number of elements in A will be from minus 200 to 200, minus 200 to 200, which will be 200 minus minus 200 plus 1, which is 401. Basically, 200 negative numbers, 200 positive numbers, and a 0. So there are 401 elements which add up to 0. From here, we have to take out 399 elements. And therefore, 2 elements will be remaining. The sum of these elements is either plus 1 or minus 1. The sum of the entire thing is 0. So correspondingly, the sum of these two elements should be minus 1 or plus 1. So that when we add this, it becomes 0. When we add this, it becomes 0. So getting 399 elements is the same as choosing two elements from A such that their sum is minus 1 or 1. If the sum of two numbers is 1 or their difference is 1, they have to be consecutive numbers. So starting from 0 to 200, in how many ways can we choose two consecutive numbers? This could start from 0, 1, 1, 2, 2, 3, and so on, and can go up to 199, 200. So overall, from 0 to 1, the first number could be any number from 0 to 199, and therefore there are 200 cases possible. Since we are adding them, the one of them has to be negative, the other has to be positive to get the difference. So what we do is, in each case, either we can have the minus sign here on the first number, or we can have the minus sign on the second number. So here the sum will be minus 1, here the sum will be 1. When we look at 1 and 2, in one case we have negative in the first number, in the second case we have negative in the second number. So we'll get the sum as here 1, here minus 1. And both cases for minus 1 will have been formed. For example, if I want a sum of 1 or minus 1 with 1 or minus 1 in 1, with 1, the only possibility is that sum will be minus 1, which can happen with 0. Or with 2, we can have a sum of 1. These are the two possibilities. Minus 1 with 0 will give a sum of minus 1. Minus 1 with 2 will give a sum of 1. As you can see, this has also been counted. This has also been counted. So we first look at two consecutive numbers. The first number could be anything from 0 to 199. So 200 cases. For each case, we can put the negative sign in the first number and the second number. So two cases from there. So a total of 400 cases are possible, in which case we can choose two numbers which will add up to minus 1 or 1. And correspondingly, the remaining 399 will also have a sum of minus 1 or 1. Hence, D becomes the answer. Now, if you're doing this for the first time, I would say this is a difficult question because even though cracking the fact that two numbers are required might happen quickly, but making cases and how the cases are to be counted is a challenge in itself. So once you have cracked it, even then, 3 odd minutes is quite easy for easily you'll require to solve this question, an overall difficult question. A certain number of children are standing in a row, all of them facing north. So this is north, the upward position is north. They're standing like this. There are twice as many girls in the row as there are boys. So if the number of boys is x, the number of girls is twice of x, which is 2x. From the west, so this will be west, this will be east. From the west end of the row, Ajay is 8th among the boys. Ajay, 8th among the boys and 17th among the children. So from here, if we look at it, there are 16 students on the left of Ajay from the west, and therefore Ajay is 17. Also, this is amongst the students. And if we look at amongst the boys, Ajay is 8th. If Ajay is 8th, 17th among the students, 8th among the boys, so there have to be 7 boys to the left of Ajay. Starting from the west end of the row, from this end of the row, there are Ajay said 8th amongst the boys, so 7 boys to the left of Ajay. Ajay is facing towards north, everyone is facing north. 17th amongst the children, so 16 students to the left of Ajay. From the east end of the row, so this is north, this is east. From this end of the row, he is 20th among the children. So if Ajay is 20th among the children, that means there are 19 children or 19 students to the right of Ajay. Therefore, he is 20th among the children. East, from the east end of the row, how many boys there are to the right of Ajay? Now, if you look at the total number of students or children, there are 16 to the left of Ajay, then there is Ajay, then there are 19 to the right of Ajay. The total number is 16 plus 1 plus 19, which becomes 36. 36 is the number of boys and girls, so x plus 2x is 36, which means 3x is 36 or x is 12. The number of boys is 12. And there were 7 boys to the left of Ajay. 8th was Ajay. So if we look at the number of boys remaining, 12 minus 8 is 4. So there will be 4 boys towards the right of Ajay. How many boys are there to the right of Ajay? Option B, 4. I think in terms of level of difficulty, the concept is not very difficult. There might be some confusion with the numbers, might be there, but in any case, 2 odd minutes should be good enough to get this answer correct. X is the largest sum of rupees which can never be paid using any number of the denomination 4, 8, 13, and 18. Now see, this is a multiple of 4. This is a multiple of 4. This is a multiple of 4 plus 1. This is a multiple of 4 plus 2. And therefore, if we look at numbers that might not be formed, they are multiples of 4 plus 3. So out of these numbers, clearly 1, 2, 3 is not possible. 4 is then possible. Then 5, 6, 7 will not be possible. 8 is then possible. Till now, I cannot form any odd number. So 9 is not possible. Also, I have just two multiples of 4. So 4a plus 2 is not possible. So 10 will not be possible. 11 will not be possible. 4 plus 8, 12 is possible. Then we have 13. 14, 4a plus 2, still not possible. 15, 15 is 4a plus 3. So 11, 12, 13. 14 not possible, 15 not possible. 16 can happen, 8 and 8 is 16. 17, 13 and 4 is 17. 18 is possible. If we look at 19, 19 is 16 plus 3. Again, that will not be possible because we do not have any such number. 20 is possible, 8 and 12 is 20. 21, 8 and 3 is 21. 22. 22 is uh, 22 is 20 plus 2. So 18 we have, 18 plus 4, 22 we can get. 23. 23 is 20 plus 3. Again, because 4a plus 3 is not present, we will not be able to get that number. 24 is a multiple of 4, so 4, 4, 4, 4, 8 plus 4 plus 4 plus 4, whatever can happen. 25. 25 is 24 plus 1. So we'll use this number, 13. 25 is 13 plus 12, and 12 can be created. So 25 can happen. 26 is 24 plus 2, so 26 can be 18 plus 8. again, both can happen. 27 is 24 plus 3. This will be an issue again, because if we subtract 13 from 27, we're left at 14, which we are not able to create. And there is no other odd number. So 27 can't happen. 28, 28 is a multiple of 4. So 4 7 times will happen. So this is not possible. This is possible. 29, 29 will be 28 plus 1. Or take out 13 from 29. 13 plus 16 is 29. Both 13 and 16 are possible. So 29, 30 is 4k plus 2, which can happen. 31 is 4k plus 3. Now, this is the first number that will happen because 18 and 13 is 31. And from this number onwards, every number will happen because now we have a number which is 4k plus 3. We already had numbers which are 4k plus 1 and 4k plus 2 and 4k. And therefore, after this, every number can be formed. So the largest number that cannot be formed is 27, which will have the sum of digits as 2 plus 7, 9. Basically, what I'm saying is the first odd number is 13, 4k plus 1. To get the number of the format 4k plus 3, we have to add 4k plus 2 or multiply this by 3. So 13 into 3 is 39, 13 plus 18 is 31. Once we reach 31, beyond this point, 4k plus 3 can also happen. And therefore, the largest largest value of x which cannot be formed using these denominations is 27. We don't have to go from 1 to 27. We simply look at the first 4k plus 3 number that happens, which is 18 plus 13, 31. The one before this, that is 31 minus 4, 27, becomes the largest number that cannot be formed, and that is the answer. Again, even if you're starting from the first number, we would be able to eventually reach if done properly. But I think overall, this is a difficult or a high level of difficulty question, which unless done earlier might not be something that we'll be able to do in the exam. 2.5, 3 minutes definitely to solve this question. A bag contains 35 tokens, number 1 to 30. 5 of them are picked randomly and are found to have 5 consecutive numbers, 1, 2, 3, 4, 5. If the product of the 5 numbers is p, how many distinct values that p can assume are multiples of 16? Oh. To be a multiple of 16, the power of 2 has to be 2 for it 4. Now, if we start from numbers with 1, 1 into 2 into 3 into 4 into 5 will have power of 2 as only 3. 1 from here, 2 from here. 2, 3, 4, 5, 6 will have power as 1, 2, 3, 4. So this will be a multiple of 16. 3, 4, 5, 6, 7. Again, there are only two even numbers. 4 will have a power of 2 as 2, 6 will be 1, so not a multiple of 16. 4, 5, 6, 7, 8. Now, once the 8 is there, 8 has a power of 3. Combined with 6 and 4, this will become 2 raised to power 4 for sure. As a matter of fact, we just need to multiply one of the 2's with 8 to get the answer, or power of 2 as 4. So as 8 shifts here, I am looking at consecutive numbers. 8 was the last number, then 8 will be the second last number, 5, 6, 7, 8, 9. Then 8 will be the third last number, 6, 7, 8, 9, 10. Then 8 will be the second number, 7, 8, 9, 10, 11. Then 8 will be the first number. In all of these cases, there will be at least one even number apart from 8, which will get multiplied to 8 to give 16. So from 1 to 8 being the first numbers, the cases that are acceptable are 2, 4, 5, 6, 7, 8. So out of 8, 6 cases are possible. Then we start with 9. 9, 10, 11, 12, 13. A similar problem happens. 10, 11, 12, 13, 14. This will be acceptable because we'll have a multiple of 4, a multiple of 2, and a multiple of 2. 14, 11, 12, 13, 14, 15. Again, a multiple of 4 and 2. So this will not be a multiple of 16, just a multiple of 8. This process will again repeat the moment we get 16. Of the next eight numbers, again, six of them will be multiples of 16. So what I'm saying is, out of eight numbers, when I say eight numbers, I'm saying the starting number of the five consecutive number, six cases are possible. So out of 32, 24 cases will be possible. But 32 is not the number that we have. The last number that we can go up to is 31, 32, 33, 34, 35. Yeah. This is the last case that we will have. Now, out of 8, 6 cases were possible. So, out of 32, 24 cases are possible. But the case where the number starts with 32 is not possible for us because we have tokens only till 35. So, we remove this one case. So, out of numbers starting from 1 to 31, 23 cases will be such that we'll get a product which is a multiple of 16. Hence, A becomes the answer. Again, I'd say this is a moderate to difficult level of question. 2.5 to 3 minutes easily to solve this question if you're especially doing it for the first time. See, it also takes time to figure out how to count the cases, and that is where the attempt time increase. Once we know what to do, of course, the attempting it becomes easier. But to figure out what to do in such questions is a challenge in itself. And if we get into that iterative cycle of figuring out what to do, it can end up taking a lot of time as well. So, if in the first 1.5 minutes we are not able to figure out where we are going in a test, it is advisable to leave such questions there. N is equal to a raised to power 4 plus b raised to power 4, c raised to power 4 plus d raised to power 4 till 31 terms, where a, b, c, d, etc. are distinct prime numbers. N is divisible by 30. Since it is divisible by 30, it is divisible by 2, 3, and 5 individually. Which of the following are definitely true? One of the numbers is 2. All of the numbers are prime numbers. Suppose if all of the numbers are odd, 31 odd numbers added will give us an odd number. It will not be divisible by 2. And therefore, if I take the first number to be 2, for example, we are left with 30 odd numbers. The sum of 30 odd numbers will be an even number plus an even, which will be even, so divisible by 2. And yes, therefore, one of the numbers has to be 2. So n is of the form 2 raised to power 4 plus b raised to power plus c raised to power 4 and so on. One of the numbers is 3. Is one of the numbers 3? Suppose one of the number is not 3. All other numbers or all other prime numbers will be of the form 6k plus 1 or 6k minus 1. When these are divided by 3, in both cases the remainder will be 1 and 1. 6k plus 1 divided by 4 will give us a remainder of 1. 6k minus 1 will also give us a remainder of minus 1 raised to power 4, which is 1. So from here we will get remainder when divided by 3 as 30, because there are 30 terms. So this will be divisible by 30, and 2 raised to power 4 is not divisible by 30. So n will not be divisible by 30. That cannot happen. And therefore, what we're doing is, if we put one of the numbers as 3, what we have is 29 other numbers, other prime numbers, each of them leaving a remainder of 1 when divided by 3. And therefore, we'll get 29 from here, 2, 4, 8, 16 from here. This is divisible by 3. 29 plus 16 is 45, which is divisible by 3. So if we make one of the digits as 3, the entire n becomes divisible by 3. So this is also true. Third, one of the numbers is 5. Now, if we look at any prime number, apart from the one ending in 2 and 5, 2 becomes even. Apart from 5, there will be no other prime number ending in 5. So if there is no number, or one of the numbers out of this is not 5, all the prime numbers will end in 1, 3, 7, or 9. When raised to power 4, the unit digit of all of these numbers is 1. 1 raised to power 4 is 1, 3 raised to power 4 is 81, 7 raised to power 4 is 240, it will end in 1, 9 raised to power 4 also ends in 1, 81, 9, 9191. So if none of the numbers is 5, out of 31, this will become 16, 3 will end in 1, and there will be 28 other numbers which end in 1. The unit digit of this will be 28 plus, so 29 other numbers, not 28. The unit digit of this will be 29 plus 130 plus 6, 36. Such a number cannot be divisible by 6. So if we want the number to be divisible by 5, we take one of the numbers by 5. Now there are 28 numbers left. So the unit digit will be 6 plus 1 plus 5 plus 28 or 8. 8 plus 5, 13 plus 1, 14 plus 6, 20. So this will end in 0 and therefore become divisible by 5. And therefore all three individually are correct. Option D. Level of difficulty definitely moderate. And unless you're very clear with the divisibility rules and how to find the remainders, this question might be difficult. But if that is okay, might should be able to do this question about 2 to 2.5 minutes. In how many ways can 1000 be written as a number of n consecutive natural numbers where n is n where n is greater than 1? Suppose I write a1 plus a2 plus a3 so on till an is 1000. Now the average of these numbers uh, will can be calculated. Now if n is odd, let us take two cases. First, when n is odd. When n is odd, in that case, if there are n consecutive odd numbers, or rather odd, when n is odd and there are consecutive numbers, the average is the central number, which has to be an integer, and therefore, when n is odd, 1000 has to be divisible by n. Find the average. So what I'm saying is, the only possibilities of n is odd and it divides 1000 is 1, 5, 25, and 125. 1 obviously is not to be taken because n is greater than 1. When n is 5, the average of the numbers will be 1000 upon 5, which is 200. And therefore, what we can do is we can write two numbers less than 200, which is 198, 199. Two numbers which is more than 200. These are five numbers which will add up to 1000. Similarly, when n is 25, we will have the average as 1000 upon 25, which is 40. So we can write 40 as a central number. 12 numbers less than 40, 12 numbers more than 40. So these 25 numbers will add up to 1000. We have two cases. When n is 125, the average will be 8. So 8 becomes the central number. Now we need 64 numbers. 125, the central number is 8. 124 numbers left, therefore 62. 62 on the left, 62 on the right, numbers. So here we'll get into the negative territory. We were looking at consecutive natural numbers, only positive. So this case is not counted. So we get two cases for 5 and 25. When n is even, and we have consecutive numbers, even numbers, the average is the central or the average of the two central numbers. So the average will end in 0.5 or zero point 0.5 to be precise. And therefore, 1000 has to be divided by n in such a way that we get 0.5. Now, if we divide 1000 by 2, we get 500. 500 cannot be the average of two integers, two consecutive integers. When integer average has to be 0.5. If we get 1000 upon 4, which is 250, again not possible. 1000 upon 8, we get 125. 1000 upon 16, we get 62.5. This is possible. Now, if I write 16 consecutive numbers with average 62.5, there have to be 8 numbers which are less than 62.5, 8 which are greater than 62.5. So 8, 55, 54. Starting from 55, 55, 56, 57, 58, 59, 60, 61, 62. And then 8 more numbers here up till 70. If we add these 16 numbers, we will get the sum as 1000 and their average will be between 62 and 63, which is 62.5. So when n is equal to 16, we can still have a case. So these are three cases. If we divide 1000 by a higher power of 2, the average will become 0.25, which should not happen. And when we are looking at uh, consecutive numbers, if the number of numbers is odd, the average has to be integral. When the number of numbers is even, the average has to be 0.5. So these are the three cases possible. Hence, option D becomes the answer. In terms of level of difficulty, it's definitely moderate to difficult question. Even if we work with factors, the odd factors are very easy to spot, 5 and 15. This sometimes does get missed, and therefore, I'd say about 3.5 minutes to solve the question easily if you're not explaining it. Even then, it will take 3.5 minutes to solve. ABC is a three-digit number with distinct digits. So ABC are different values. It is known that ABC into 3 is equal to another three-digit number CCC. What is the value of B? So when we multiply 3 to C, we should get a number ending in C itself. 1 into 3 ends in 3, not 1. 2 into 3 ends in 6, not 2. 3 into 3 ends in 9, not 3. 4 into 3 ends in 12, not 4. 5 into 3 ends in 15. So this is common. This is possible. 6 into 3 ends in 18, not 6. 7 into 3 ends in 1, not 7. 8 into 3 ends in 24, not 8. 9 into 3 ends in 27, not 9. So only in one case is this number and this digit same. Also, if C is 0, everything will be 0. So AB, C has to be 5 for sure. And we need a 3 here. So the answer has to be 555. Now, when we multiply 3 by 5, we get 5 to 15, carry forward 1. To get a 5 here, now we can simply divide 5 by 3 and get the number. Or I'm saying 3 into this number should be a digit which added to 1 gives me 5. We can see we have a 4 here. So 8 threes are 24 plus 1 becomes 5. Carry forward 2. We have a 5 minus 2. So we need a 3 here. The 3 ones are is 3. So 185 into 3 gives us 5, 1, 24, 5, 2, 5, 5, 5. And therefore the value of B is 8. I would say this is one of the easier questions in the test and should be attempted. Once you crack it, hardly a minute to solve the question. Let M be the set of all even numbers from 1 to 25. So M consists of 2, 4, 6, 8, 10, 12 up to 24. All even numbers from 1 to 25 and all odd numbers from 26 to 200. Okay. So 26, 27, 29, 31 up to 199. If all the elements of M are multiplied, find the number of zeros at the end of the product. So here we have to count 2s and 5s. The power of 2 in M will be from the first part only because that is the only even part. So this will have 2, 4, 6, 8, 10, 12, 14, 16, or what we can do is we can count the power of 2 in 25 factorial. The power of 2 that divides 25 factorial will be the same power which divides the product of all even numbers from 1 to 25. 25 by 2 is 12, 12 by 2 is 6, 6 by 2 is 3, 3 by 2 is 1, 18, 3, 21, 22. So M will have the power of 2 as 22. Then we look for power of 5s. Now for 5, from 1 to 24, we will have 5, 10, 15, and 20. That's about it. So this gives us 2 raised to power 22 into 5 raised to power 4 is what we get. Now we are looking at odd multiples of 5. Starting from 26. So the first multiple of 5 here will be 5 into 7. Then we'll have 5 into 9 and so on. The last multiple of 5 here will be, because they're only odd numbers, 5 into uh, 39, which will be 195. So the number of fives outrightly that we get from here will be numbers from 7 to 39 and only odd numbers 7, 9, 11, and so on. The number of odd numbers will be 39 minus 7 upon 2 plus 1, which will be 32, 17. 7, 9, 11, 13, 15, 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39. Next, if we look at these numbers and we look at another further power of 5, 7, 9, 11, 13, 15. So we'll have 5 into 15 somewhere, which will give us another 5. We'll have 15, 17, 19, 20, 21, 20, 25 into 25, which will give us two more 5s. 25, then 30, we'll have 35, 5 into 30, which will give us one more 5. So the number of 5s in M will be 2 raised to power 22 into 5 raised to power 17 for 21 and 25, and then so on. The number of zeros will be formed from 2s and 5s. 2 is the limiting factor, and therefore there will be 22 zeros in this case. Again, level of difficulty, I would say moderate to difficult, easily 2.5 to 3 minutes to solve the question. Let ABC be three distinct positive integers, distinct positive. If the product of AC is even, either one of them is even or both are even, and C into A plus B is odd. Product of two numbers is odd. This will only happen when C is odd and A plus B is odd. This is for sure. Also, A into C is even, and we know C is even. So A into C even will happen only when A is even. Also, since A plus B is odd and A is even, B has to be odd. So we know the three numbers. C is odd because of this product. Since C is odd, AC even means A is even. And since A plus B is odd, A is even, so B is odd. We know about ABC. Which of the following is are always true? A minus B into A square plus B square is even. A minus B. Even minus odd, this will be odd. Even plus odd, this will be odd. Odd into odd is always odd. This is false. A is even. Even into even plus odd is odd. So this will also be odd. C minus A. Odd minus even, which is odd, into B odd is odd. So this is true. Hence option C is true. Again, I think this would be an easy question. Maybe 90 odd seconds to solve the question. Even if directly odd and even does not becomes apparent, we can choose values and then solve from there. A florist sells only two kinds of flowers, uh, rose and tulip. On a particular day, he sold 70 roses and 90 tulips if none of his customers bought more than one flower of each type. For each type, everyone bought not more than one flower. So one or zero flowers of each type. What is the minimum number of customers that must have visited his shop on that day? So the customers will either buy rose or tulip, or both one rose, one tulip, or both one. There are 70 roses, 70 tulips. So suppose all these people who bought roses also bought tulips. So none of the person bought a rose alone. Anyone who bought a rose, one flower of each type. So if they bought a rose, they also bought a tulip. So 70 of the tulips are done, which means 90 tulips are left. So there are 70 people who bought one rose plus one tulip, and there are 20 people who bought only one tulip, and therefore 90 people minimum are required to buy 70 roses and 90 tulips when none of them are buying more than one flower of each type. Again, not a very difficult question to solve. 90 odd seconds should be good enough to solve this question. So as I was saying initially, overall level of the test, easily a test which is towards the higher level of difficulty. 5 to 6 questions would be a very good attempt, and 25 odd minutes definitely to just solve the paper individually, right? Which questions would I choose to get the 5, 6 questions correct, and therefore a 95 percentile? For me, in a test like this, they will be 2, 4, 7, 9, 10, which are the not this because cases are to be formed. Getting the negative, counting the case was a little difficult. Certainly, this just ordering numbers. There is a possibility of missing a case here or there. So not this in an exam. I would have done this because the number of cases were pretty clear, and I we had to count from 1 to 30, 31. So even if I had to write all the cases, I would not miss out a case. So might have done this. Uh, Again, if you are comfortable with the divisibility test and the fact that the last digit of the numbers, then this might have been attempted, otherwise not. This kind of a question for the first time I would not attempt in a test. Would have done this every single time. Just basic getting 5 into 3 is 15 gets me the answer. Uh, might have looked at this, but there is chance of confusion, especially in the second part when we're looking at multiples of 5. It is easy to skip out the extra multiples, or even definitely doing this in every examination. Uh, would have done this as well. So my attempt would be 2, 4, 7, 9, 10.